So we're now going to take a look at a multi-part case study, which is going to demonstrate different concurrency models in a Rosetta Stone-like way where we can compare and contrast them for the same application semantics, the same requirements. And so in general, this ex4 will take a look at the design and performance of a bunch of Java concurrency models. And we're going to start looking at Java structured concurrency. And we're going to use I/O-bound tasks here. So up to this point, we've been looking at compute-bound tasks. We're now going to take a look at I/O-bound tasks, where we're going to download a bunch of images from a website or from different websites, different URLs, and store them. This solution, we're going to look at first, uses classic Java features. We'll look at other ones that use other features. So let's go ahead and take a look at this. And you can find this example in the ex4 folder, in my Loom folder, in my Live Lessons GitHub repository. So we're in the ex4 folder in my Live Lessons GitHub repository. I'm looking at the ex4 project. And you'll see there's a bunch of different examples here. And we're going to take a look right now at a couple of them. One that's going to use the Java structured concurrency, the kind of the classic. And then we're going to look at one that uses the hybrid model, which kind of combines Java streams and Java structured concurrency. So let's go ahead and take a look first at the main program. And this particular program will ultimately be used to compare and contrast a whole bunch of different concurrency models, so you can evaluate them in terms of their performance and also in terms of how you design programs using them. You can make a choice about which ones you like best. So when the program starts, we print out the number of cores. It'll be 10 on my MacBook Pro. And then we're going to go ahead and run tests. And we're going to run structured concurrency tests, and a hybrid structured concurrency test, and a parallel streams test, and a completable futures test, and a project reactor test, and an RX Java test. And because these take a while to run, I'm just going to start running them in the background. And we'll continue looking at this. So here's the run test method. So what the run test method does is, if it's not a warm-up, we're going to go ahead and time how long it takes to run the test. So structured concurrency, parallel streams, completable futures, or whatever, which is passed in here as something called a consumer. So we're going to run this thing, and we're going to time it. And the way we time it is by using a little class here that I've written a long time ago called run timer. I use this for lots of stuff. So it takes into account how long it takes to run computations. And in this case, we're going to pass in the runnable that we want run and the test name. It's going to start the timer, run the test, stop the timer, and it's going to store the results into a map for later processing and later printing and displaying and so on. So that's what run timer does. And you'll see that gets used a lot. After we're done running the test, we delete all the downloaded images, just so next time we start up the test, it'll be in a pristine state. OK, so let's go ahead and take a look at some of the tests. And in fact, we'll start by taking a look at the one that's the first one, which is the structured concurrency test. So let's go take a look at that. So here's structured concurrency test. It's the run method that does the test. Give it a name, the name of the string, so we can keep track of that for diagnostic purposes. And you can see that we've got three primary sub-methods in this implementation. We're first going to download the images from a list of URLs, and we're going to get back a list of futures to images, because we're going to use structured concurrency to do this. We're then going to take that list of futures to images, and we're going to transform them, and that's going to apply image filters to them to do stuff to the images. And then we're going to take that list of transformed images, and we're going to go ahead and store them. So we have downloaded images, which is a list of futures to images, transformed images, which is a larger list of futures to images, because we're going to transform each image multiple times and apply filters multiple times. And then we're going to end up here, once we store them, with a list of futures to files. So we're going to have stored them in the file system as the result of all this stuff. And then when we're done, we're going to print out, so say, we processed this many images. So let's start by taking a look at download images. So this should look kind of familiar by this point. We take a list of URLs. We make a new StructuredTaskScope shutdown on failure block. We make ourselves a new array list of a list of futures to images. I did this syntax slightly differently from I did with my previous example, just for kicks. We then iterate through the list of image URLs, and we fork off a virtual thread that will download the image, and it'll download the image. So download image here will, as you can see, take the URL and download it. And here's what you do to download it. You open up a stream to the web server, and then you read each thing in a chunk at a time, a buffer at a time, and we end up, when we're all done, with the image that's been read in. And that's going to block. So this shows that you can use Java Virtual Threads even with IO-bound tasks, which we're doing here. And this doesn't store in a file. It stores it in an image object, which is in memory. So you'll see here that we keep doing this until we're done. Just for kicks, I decided not to use a try-catch block, although I probably could have done that here. Wouldn't have hurt anything, really. So I use my little exception laundering adapter that converts a checked exception into a runtime exception. But long and the short of it is, scope doesn't exit until all the concurrent tasks complete. So we download everything. And when we're done, we return the list of futures to downloaded images, except they really are images at this point. They're not futures. But that's just the way that Java concurrency, Java structured concurrency, wants to treat these things, which I said before is a little bit awkward in some ways. All right, so that's download images. Now we're going to transform the images. You can see what we do. Again, we make ourselves a structured task scope, and we're going to go ahead and have a loop for each downloaded image. Remember that the downloaded image was a list of futures to images. And for each of these things, we're going to call another helper method called transformImage, which takes in the scope and the get method, so we can get the flipping thing. Although I think we could probably also use result now. Would work the same way. And then we're going to add the results here, because there are going to be multiple results coming back for each image, because we're going to transform it with multiple filters. We're going to add those results to the end of this list. And so let's go take a look at transformImage. TransformImage takes in this executor. That's actually not an executor. Let's call it something more meaningful. Let's call it scope. Better name. In this case, we're going to go ahead and make ourselves a list of futures to transformed images. And we're going to go through each of the transforms. There are going to be multiple transforms to apply image filtering in different ways. And for each of those, we're going to go ahead and fork off yet another virtual thread, which will transform the image and then add it to the end of the transform image futures list. So all of these guys are going to go off and run. But because this is structured concurrency, by the time this is structured concurrency, but we're going to go ahead and fork these things off, return this list of futures, but those computations can still be taking place. They will still be happening. And so we don't know if they're done at this point. All we do is we add futures to this list. So if you take a look, we were in the, whoops, back up here. We had got a list of futures we plucked on there. And those things may not finish until we reach join. So when we hit join here, there's going to be a bunch of futures running around in virtual threads, or a bunch of processing running around in virtual threads, doing the transforms, which could take a while, depending on how complicated the transform filters are. And so we're going to end up with this list of these things, but we will not move past join until all that computation is done. And again, let's assume there's no exceptions, but if there were, we could throw the exceptions. And once again, we return the list of transformed images. So the final thing we've got here is now we have a list of futures to transformed images. There'll be more of them because we apply multiple filters to each image. And then we're going to call store images. And this is going to start kind of looking boring at this point because you've seen this a million times before. But we're going to go ahead and make ourselves a new shutdown on failure object in the try with resources block in that scope. We're going to make ourselves a list of futures to files this time because we're going to store these things. And what we're going to do now is we're going to go through each of those images that were downloaded and transformed. And this time, we're going to fork off a virtual thread that will store each of them. And we just use a little method here called storeImage. We give it the result of all this stuff. And let's go look at storeImage real quick. Store image just writes the image to the disk. And you can look at it if you're curious to see what it looks like. But basically, it makes a new file with the right name, and it writes the contents to the file. And writing to a file could take some time, so perhaps that motivates the use of structured concurrency to do all those things in parallel. Once again, we wait till everything's done, and we return a list of futures to files. And that's what comes back here. So that's the first example here. This is the one that uses kind of classic Java structured concurrency. And we'll take a look at some other variants in just a second, but that's the first one we're going to look at.